Hello and welcome to another tutorial on Mathematica. So this video is about the basics of list. The plan for the video is as follows. We're gonna talk about the structures of list, first topic. The second one will be creating list, displaying list, and finally some basic operations on list. Now you might wonder why we have to talk about take one video for list, and it's because list are the fundamental data structure in Mathematica, and they group objects together so nicely. They have a lot of applications, and that's why we spend just one video talking about what lists are. All right, so let's look at the structure of list first. So as you can see here, we have a list. A list is always going to be open with curly braces and closed with curly braces. And a list can have any type of data inside it, separated by commas. So here we have a float, a whole number, a string of characters, a picture, another list, and the empty list. So a list can have any type of data inside it. So you can group pictures, numbers, strings all together in the same list. So here, when we have the list, you can call elements of the list. If you give it a name, in this case, we label this list as A. You can call element of the list by typing A, and you type double square bracket. And for example, let's say we look at the first element. So the first element here will be 2.5. Similar, we can talk about other elements in that list. So for example, let's say the fourth element in that list, the fourth element in that list is that picture. So you can put all of these structures together in one single list, all of them. Now, how do we create lists? So one of the things that you need to do, instead of, like, of course, making a list by hand, is trying to do some creation of lists with automatic functions that Mathematica has. So one of the things that Mathematica has is the function range. And the function range, what it's going to give you is going to give you the range of numbers up to a certain point. So in this one here, range of 10 will give you all the numbers from 1 to 10. And you can also specify what in a range, like the function here, what this will do. So if I want all the numbers, and these are whole numbers, by the way, between 3 and 20, for example, then that will give us all the numbers between 3 and 20. Now you can also specify the step, so it doesn't have to go by one like it is right here. You can also say something like range, and we can start, for example, at 2, go all the way up to 21, let's say, and let's take a step of 3. So this is gonna start at 2 here, and it's gonna add 3 until you get to the upper limit 21 there. So it's gonna be all the way from 2 to 20, because if you add 3 to 20, it's gonna go over this upper limit that is here. Now you can these functions for whole numbers, but range is more flexible than that. You can also do range, for example, for decimal. So if you start range, and let's say I want to start at 1.2, let's go all the way up to, let's say, 3.5, and let's go into the steps of 0.5. Now that's going to give us the range started at this number 1.2, and then at 3.5 with steps of 0.5. So that's going to give us this list. Now that's one way to do it, one way to create list. Another way to create list is by looking at the function that is called table. Table is a very flexible way to create list. So let's look at table here. Now, by the way, whenever you are want to see something, how something works, when you're typing, Mathematica is going to give you this a suggestion, and when you click on I, it's going to bring up the help from Mathematica, and you can just look at what it does basically here. So all the explanation is there. Now let's look at table here, and we can use table to create lists that have a generating a specific formula. So for example, let's say we're gonna create a list of all the powers of 3. So let's say 3 to the k, and let's say 3 to the k, and then we have to specify the values of k. K is starting at, for example, here. So, and we're gonna see these curly braces here is gonna indicate first the variable, or what we call here the iterator variable, the starting point of that iterator variable, which in this case we can, let's say we do it at 1, and let's say we go all the way to 6. So I'm gonna close here with brackets. So this is the function of the formula for to generate the list. Here in this part, you're always gonna put the iteration variable, which is k in this case, the starting point and the end point. And if you don't put anything else, it is assumed that you go one by one. So start 1, 2, 3, up to you get to 6. So you see, you will get all the powers, 3 to the first, 3 to the second, 3 to the third, and so on. Now, if your table starts at 1, you can actually ignore the 1. So Mathematica understands that. So let me copy and paste the same thing, so I have to type all the same thing. And let's say we use another formula. So let's say k square, and I'm gonna start, let's say, at 1. So I don't have to write down the 1 there. And let's say we go all the way to, let's say, for example, 8. So that will give me k square. K goes from 1 to 8 in the steps of 1. So I can ignore the 1 there. That's gonna give me all the squares of k. K starting at 1 and ending at k, one by one. Now, if you wanna create a list that does not have a variable here in this formula, you can also ignore the iterator list variable from your list. So for example, if you're gonna create a list of zeros, you just put 0 here. Now there is no variable there, so you just ignore that. So let's say we want to create a list of 4 zeros. So open and close curly braces, and let's put let's say how many there. So 4. Close the table here, and then that's gonna give me a list of 4 zeros. Now that is, you can ignore the variable here if you don't need a variable here and generating your list. You can also do that, for example, with something like this. So let's say table, and let's generate a list of random real numbers. So let's say random real number. So let's put this one here. And if I ignore the input of random real, it's assumed that this is gonna be a number between 0 and 1. And let's say we want to generate a list of 6 of them. So let's say 6 here, close the bracket there. So that's going to give me a list of 6 random number between 0 and 1. The reason I can ignore the iteration variable here is because this function that is here does not take any variable. So it's going to give me a list of random six random numbers between 0 and 1. And if you enter again here, so let's evaluate this again, that list is going to change because of the random part here of this function. Now, tables can create list of any type of objects. Now, this here is a list of all numbers, but you can also create a list of, let's say, for example, plots. So let's see that. So let's look at the next thing. So let's say I'm going to create a table. Say here table, and I'm gonna create a table of plots. So I have to specify what kind of plot I'm gonna get here. Now let's say I wanna plot, and we talked about plot in the basic tutorial for Mathematica. So let's use some Bessel functions, Bessel J here. The Bessel function always takes 2 parameters. One is gonna be the n. The other one is going to be the variable x. So that's going to be that one. And then here after Bessel, I have to specify the range of the variable x. So where I'm going to plot the variable x here. So the variable x, let's say, goes from 0 to 10. And that will give me the plot of this function, the Bessel function, from 0 to 10. And of course, x here varies from 0 to 10, but I'm gonna do a table of those things. I also have to specify what is my values of n. So let's say the n here is, so here it is important to have the iteration variable there. So the n, let's say, goes from 2 to 5. So this will give me a table or a list of plots of this function when the iterator variable here is n going from 2 to 5. So that's going to be the list of the Bessel. So you see here the curly braces indicate that each one of this here is an element of the list. So I can manipulate that list however I want it if I have named this, for example, L or T or whatever I name it. So that's, so also, so remember, table is also as flexible as list because you're going to basically create a list. So you can create a list of plots or other sublist also like that. So let's actually look at that. Let's see how we're going to create, let's say, a list of list. So the table, we're going to use also table for this. So let's look at creating a nested list. So list containing other list. So let's look at this example. Let's say so table, and I'm going to have a table. The formula that generates that table is going to have two variables, I and j, and I'm gonna give the range for both of those variables. So let's say the variable j here in this case is gonna start at 1 and ends at 4, and let's say the variable I is gonna start at 1 and end at 3. So this is gonna give me a list of lists. Now, before I explain what this does, let me just press enter here and see what we get. So what you see there is a list of lists. So the main list is this one here, from here to here. And then we have a list of sublists. Each one of them is a list. Now, how this works here, the reason how this works, so how this is evaluated, is gonna depend on actually the order in which you put these iterators, and I will explain that a little bit better. So this is what I had in Mathematica. So I wanted to explain to you a little bit better what the code is doing. Now this is what we call the J, the one that is closer to the formula, is what we call the inner iterator, and the one that is farthest from the formula here is called the outer iterator. Now the order of this is important. And let's look at that now. Every value of the inner iterator here, which is the j, creates a sublist. Now, because j goes from 1 to 4, that's going to create 4 sublists. And this I indicates that every sublist will have 3 elements because I goes from 1 to 3. Now, the important part here is for j here, so for the inner iterator, you're gonna start the inner iterator first. So the inner iterator is gonna be fixed, and then I is gonna take values after that. So you fix the j first, and then the I takes values. So let's look at that. So if j is equal to 1, I is gonna take values from 1 to 3. Now the formula is I plus j, so it's gonna give me I plus 1, because here this 1 is the j, and it's gonna give me the list I plus 1 when I takes values from 1 through 3. So it's going to give me 1 plus 1, 2 plus 1, 3 plus 1, which is this list 2, 3, 4. Then j takes another value. That's the inner iterator. And once the inner iterator takes another value, then the outer iterator is going to vary. So it's going to vary from 2 to 3. So j here is 2. I plus j, this is the general formula. The j here in this case is 2. So it's going to give me this list, which gives me in turn this result here, and so on. So that's how it's important to know which one is the inner iterator and what is the outer iterator, because order here is gonna matter, and I'm gonna show you that in a second. So as I show you the order in which you do the iteration, actually it's gonna matter. So what I'm gonna show you here is, let me copy and paste this code again. So Control C and Control V. And I'm going to change the order in which this happens. So I'm gonna take this inner iterator and I'm gonna put it last. So now the inner iterator is the I and the outer iterator is the J. So in this case here, if we press enter, then the two results are completely different, because for the second part, this is the inner iterator is saying I'm gonna create 3 sublists, which is what we have here, 1, 2, and 3. And each of those sublists will have 4 elements. So that's the main difference between these two things. You have to be careful on how you do things. Now, the value of the outer iterator might depend on the value of the inner iterator. So this value of the outer iterator, you can take this value of the outer iterator depending on the outer of the inner. So let's see an example. So let's look at the same formula. So I'll actually, let me copy and paste this part. So I'm gonna say, let's say, for example, I grows from 1 to 3, and J goes from 1 to I. Now, in this case, what's gonna happen here is let's see what happens when we press enter here. So what I said was the outer iterator can depend on the inner iterator. So once this I takes the value 1, the J go from 1 to 1. So it's gonna create a sublist of only 1 element, a sublist of 2 elements, and a sublist of 3 elements. And this is gonna make sense because how this is evaluated, the inner iterator takes a value first, and once the inner iterator takes a value, then the outer iterator runs. Now, it's important to distinguish these two things because this could make you confused on what the result will be. So sometimes actually I get confused about that. Now, let me show you what happens if we do the other way around. So what happens if I put, let's say, so let's reverse here this. So now the inner iterator is J and the outer iterator is I. Now, in this case, this should give us an error. And the reason for that is because the inner iterator has to take values first, but here I is a variable. So I here is not defined yet because that's the outer iterator. So in this case, so you see here the iterator J from 1 to I does not have appropriate bounds. And that's true because we don't know what I is here. So that's basically the problem there. So the iterator can be arbitrary. So you can have iterators that are arbitrary. It doesn't have to go from 1 to and so on. So let me show you one last example here. So let's say table, and let's take powers. Let's say 3 to the, let's say P, and then plus 1. And let's say P. So P is, I have to include the variable P here because P starts here in this formula. Now P could start from 1 through 4, and I could do that, or I could do this arbitrarily. So I can actually include a list here. So P, when you type this part here, it means P is gonna take values on whatever list I put here. So I could do things like, for example, 5, 6, let's say -1, and let's say 2. So if I do that, let me close that here. If I do that, then this is gonna give me the list of 3 to the P plus 1 when P starts at 5, 6, -1, and 2. So that's gonna give me that list. So you can see there, we have that list there. So this iterator can be arbitrary. So you can put P ranging in an arbitrary list. As you can put whatever you want in there. All right, so let's see how we actually display list. So let me make a list here, and I'm gonna start with this matrix form. Now matrix form is gonna format the list that you enter as a matrix, if it makes sense as a matrix, of course. So how do you enter a matrix here? It's gonna be a list of lists. So the first list and the second sublist. So here I'm going to have a list of two sublists. So every sublist will actually be considered as a row of the matrix. So let's say we have something like -1, 0, and 2. That will be the first row. And then the second row will be, let's say, for example, 3, 4, and -4. Now, I don't need matrix form to create the list. I only put matrix form here because I want to show you how this is displayed as a matrix. So this is how you're going to display it as a matrix here. So let me create actually a variable here called math, and I'm going to create, let's say, a matrix of, let's say, random integers. I'm going to use table again for that, so I don't have to type it all. And I want to create random integers. I'm going to say random integers, the first one that you see here. And when it's random integers, you actually have to give it the range. So I'm going to give the range here from 0 to 5. So that will give me a table, and I actually have to give the dimensions. Now, I'm going to do a list of sublist, so I have a matrix. Now, this formula that is here, that is random, does not take any variables. I don't have to put the iteration variable here, so I have to tell how big it is. So I'm going to do a 3 and 3, so that's going to give me a list of 3 sublists. Each of the sublists will have 3 elements. So this will actually look like a 3 by 3 matrix. So this is a list of 3 sublists, each one of them with 3 elements. So I can also use matrix form to see how this looks like as a matrix. So if I put math here and press enter, that's going to give me the matrix there. Now, I'm going to show you something else of this plain list. So this is how you can display matrices as the way you see it, for example, in linear algebra. Now, there's also another way to look at displaying this kinds of matrices of list a little bit more with pictures. Now, I'm going to create another matrix, math2. And in this case, what I'm going to do is I'm going to actually copy and paste this code here because it's going to be very similar to what I want to do. So this is going to give you a random integer between 0 and 5. So let me just look at this and change it to 6. And I want to create a bigger matrix here. So now I don't want a 3 by 3 of random integers. Let's say I want 100 by 100. So 100 here and 100 here. Now, if I press enter right here, it's going to show me that list, but I don't actually want to see it like that. So when you want to compute something, and I'm going to store it in this variable maths2 here, I don't want to see that. So if you don't want to see that, but still want to compute it, just put a semicolon at the end, and it's going to store the result in the variable, but it's not going to display it. And that's exactly what I want. Instead of doing that, what I want to show you here is this. One way to visualize this type of big matrices is to use something that is called the array plot. So the array plot is a way to visualize matrices. Let me actually do the first one here, math here, this one right here. So this is going to give me a visualization of this 3 by 3 matrix. So let me press enter there, and it's going to give me this picture. Now you can imagine what happens here is this. The bigger the number, the darker it's going to be. So this math matrix is the one that is right here, this one. So 5 is the darker one, and 0 is the white one. So here is going to give me a visual representation of that matrix. Now, of course, that might not be ideal for something like this small, but if you have something big like this matrix here, then that will be much better to visualize. So let's actually visualize that. Let me copy and paste this code here, and let me just do the computation here. So let me copy and paste that, and that matrix is called maths2. So let's see how that array plot looks like. So that's gonna be like this. So this kind of makes a little bit more sense to visualize it like that in case you have some kind of pattern in the matrix. All right, so I just want to show you something a little bit, I think is a good way to see how this array plot can visualize things. So let me do this array plot of a list. So I'm gonna create actually a table here. So let me create a table, or I'm gonna create a list of, let's say, the function cosine of, let's say, x times y. So x times y, and I'm gonna the variable x and y here are gonna take a certain range. So here, let's say x goes between -60 and 60. And actually, I'm gonna do the same for the y. So I'm gonna copy and paste this one here for the second one, for the second part. So I'm gonna change this into a y. Now what this is gonna do here, this array plot. Now this one inside here is gonna give me a table of values of cosine of x times y. Let me put the sign for multiplication there. Cosine of x times y. So this is gonna give me cosine of x times y is gonna give me numbers between -1 and 1 here for x varying between -60 and 60, and the y the same here. So an array plot is gonna give me this kind of picture. So it's a array plot is just a way to visualize a large table of values. So it's gonna give you a way to visualize that kind of thing. All right, so that's about displaying list. Let's look at some basic operations of list. So let me create another list. So let's say I want a list that I'm gonna, let's say, label L, and I'm gonna do that the same thing with table. So I'm gonna say table, and I'm gonna do the same thing, random integer. By the way, you can create your list any way you like. If you don't want to do this, you can enter it by hand. But I just want to do it with random numbers. So I'm going to create a list of random numbers, and let's say a list of, let's say, 8 elements. Now I don't need, again here, the iteration variable because it's just a list of random integers. This formula doesn't take a variable here. So if I press enter here, it's gonna give me a random list of number between 1 and 5. I didn't get the 5, but you could have gotten the 5. Now some operations on list here is one thing you can do is called position. So position is gonna give you the position of an element in a list if it appears there. So the list is L. So let's say I want the position of 4. So I see several 4s there, and I want to know what 4 is here as a position in that list. So that is in position 2 and 4. So you see here 2 and 4. Now I can also count in a list how many elements will be there. So for example, I can say count, and let's say in the list L, I want to count, let's say, how many 3s I have there, how many 4s. So this will count the number of 4s, if there are any, on the list L. So that's gonna give me 2, of course. There are 2 4s here, this position and that position. And you can change this and check another one. Now, if you wanna check that something is in a list, you can use member Q, and member Q is gonna check whether or not something is in a list. So let's say, for example, L, comma, and let's ask for 1. So this is gonna tell me whether or not 1 is an element of that list. In this case, is true. Now, if I change that, for example, for a 5, it's gonna give me that is false. So meaning that 5 is not an element of that list. Now, there's another function called freeq. And by the way, every time you see a function in Mathematica that ends with capital Q, it's usually a function that's gonna give you true or false output. So freeq here is gonna give me an output of true or false, and it's gonna tell me whether or not a list is free of something. So let's say 0. here. So it's checking if that list is free of zeros. The answer, of course, is true because there are no zeros in that list. So for list, you can also check the length, which is right here, the length of the list. And it's going to give you the number of elements that that list has. And in this case, of course, it has 8 elements in that list. Now, let's look at a little bit more ways to operate with list. Now, I want to give you another random list of elements. Now, I'm going to take, let's say, the same thing, but now I'm going to change this by, let's say, 2. So a list of 2 sublists, and then I'm going to change this with 3, and then let's put let's say 4 here. Okay, and this gives me a way to explain that this is going to be a list of lists. It's going to be a list of random integers between 1 and 5. It's going to have 2 sublists. Every one of those sublists will have 3 sublists, and every one of those sublists will have 4 elements. Let's check that. So this is a list of list of list. So the main list L here has 2 lists, which is this one here and this one. Each one of those 2 sublists has 3 sublists, as you can see here, and every one of those sublists will have 4 elements. Now, if you ask for the length of that list L now, what do you think is going to give us? It's going to give us 2 because I have 2 lists that are list of list. If you actually want to, if you know that your list L is a list of sublists, and you want a little more information on the dimensions of this, you actually have to tap dimensions. So dimensions is going to give me a little bit more information if I have a list of lists. So dimensions here is 2, 3, 4. So it has 2 main lists, each one of them with 3 sublists, and each sublist will have 4 elements. So that's going to give me the more information that length could give me if I have some kind of list of sublists here. Now, the last thing I want to do is for that list L we just created, if we just do a matrix form of that. So let's see what that gives us. So that gives us this. So this is 2. That's going to give you the number of rows. So it has 2 rows, 3. So 3 columns. And every column is actually a matrix, which is of 4 elements. Now, there are more operations on list. And of course, this is just an introduction. So I'm going to do another video on operations of list, where there is a little bit more interactivity between them. And that's actually all I have to say for today. Thank you for watching. Take care and good luck.